So energy needs. So after going through this lesson, students should be able to research different energy sources, formulate and communicate an informed view of ways that current and future energy needs on Earth can be met. So that's what we're going to look at in this lesson. Okay, so how do we use energy and where does energy come from? So what are the forms of energy we use in our homes? Where does that energy come from? We usually flick a light switch without any thought as to what source of energy produced the electricity in the light. In order to supply homes with energy, some sources of fuel or resource must be changed or transformed to electrical energy. So ultimately all of the energy that's on the earth, it comes from the sun. And through different processes that energy is changed from one form into another. But if you take, for example, human needs, like we need electricity in our homes to carry out all the functions that we do each day in our home, for example, to light, just to switch on a light, for example. But that energy is generated in an electrical power plant somewhere, and there's different ways that we generate electricity. And two of the main, let's say, main sources of energy are we use non-renewable sources and renewable sources. So let's think about how electricity is actually generated in the first place. So if we have a look at this setup, and this just kind of gives you an idea of how electricity is generally generated, and there's many different ways that it can be generated as well. So essentially what happens is we take water. So for example, you have water here, and what we do is we heat up that water. So we heat the water up until it turns into steam. And then that steam, it has a huge amount of what's called kinetic energy. And that steam then is passed through or across a turbine. And then that turbine turns. And then what that does is it generates electricity. And then that electricity is supplied to the grid. And then that's what, when we turn on our light, for example, that electricity comes from the grid and it turns on. It generates the electricity that we need in the house. So this step here, so basically we have to boil water, turn it into steam, and then that steam is used to turn a turbine. So if you think about, let's say, if you're to look at, let's say, a water particle like this, if I add energy to it, so I'm adding energy. So what's going to happen is this will move. And the more energy that I add to this, the more what's called kinetic energy. So kinetic energy. So kinetic energy is basically the energy something has because of its motion or because of its movement. So think about a rugby player. If a rugby player runs very fast, they build up kinetic energy. And then that energy can be used to do work. So in the case of generating electricity, we use that energy to physically turn a turbine. So that, let's say that water particle, what it does is it hits the propeller on the turbine, and this turns this. So again, you have kinetic energy being turned into more kinetic energy. And then what happens then is that turns a turbine. So you can see here we have a turbine, and that kinetic energy then is turned into electrical energy. So electrical energy. So what's happening all the time is that energy is being changed from one form into another. And there's a principle that we learn when we look at physics. It's called the conservation of energy. So energy cannot be created or destroyed. It's just changed from one form into another. So how do we create this steam that has the kinetic energy? Well, what we have to do is we have to take the energy that's stored in. So what we typically do is we take the chemical energy. So chemical energy is energy that's inside the bond. So if we take, so this is carbon and it's connected to another carbon. inside this bond here, so this is what's called a covalent bond, there's loads of what's called chemical energy. And what we can do is when we burn something or when we combust, what we're basically doing is we're taking oxygen in the air and we're combining that oxygen with the carbon. And what that does is it produces CO2, okay, and it also produces a huge amount of energy. So essentially what we're doing is we're releasing the energy, and that energy will come out as heat. It'll come out as light. It'll even come out as sound energy. So think about when you look into a fire and it's burning, so you get the heat that's coming off it, you get the light, and you get the sound. And that where is that energy coming from? It's actually coming from the chemical energy that's stored inside the bonds. And then you might think, okay, well, how does the energy get inside the bonds? Well, what happens is that energy ultimately comes from the sun. So the sun, and what happens is plants, essentially what plants do is they photosynthesize. So if we remember what happens in photosynthesis, plants take in CO2 plus H2O. So carbon dioxide and water, they take that up in their roots. Then they use sunlight, and they also use chloroplasts. And what they do is they take that and they convert it into glucose, C6H12O6, and they also produce oxygen, O2. And this here is stored inside the plants. And what we look at, so essentially what's happening is the energy from the sun is being converted into chemical energy that's stored inside this glucose molecule. And then what happens is as we look at like how does coal and oil and all these what are called fossil fuels how are they produced? Well, what happens is over thousands of years they all get compressed and they turn into coal. But what's happening is that inside the coal or inside the fossil fuel, whatever one it is that you use, you have stored up energy that's been stored up there millions of years, and that energy originally came from the sun. So you get the chemical energy, we burn it, that chemical energy turns into heat energy, that heat energy heats up the water then turns into steam, so that water or steam has loads of kinetic energy, that kinetic energy turns a turbine, that turbine turning then turns the kinetic energy into electrical energy, and then we use that energy and we turn it into other forms of energy like light energy or heat energy to light or heat our homes. So this is essentially, if you like, how energy is produced. So it's very important in society that we have systems set up, electric energy generating systems that can provide the electricity that we need to give us like the modern comforts that we enjoy. But ultimately what happens is you have like coal or some other fossil fuel being burned to heat water and to turn a turbine. So this process here, this is when we talk about we use different types of energy to heat up the water. This is what we're talking about. So we want to try and be able to turn this turbine, but do it in a way that doesn't involve having to use materials that are going to run out, like coal or oil or things like that. So ultimately, all of the energy comes from the sun, but there's two types of energy sources. So we have, or two forms of energy sources. So we've non-renewable and renewable, and we're going to look at some of these now. So non-renewable sources, so think about the source of energy that we need in order to burn to heat the water. So non-renewable sources are limited resources that will run out and that we will be unable to replace. So in common terms, we call these fossil fuels. So they're basically fuels that are going to run out. And these are some of the common non-renewable sources that we use. So coal, fossil fuels like oil, nuclear material, and natural gases as well. So these are some of the non-renewable sources of energy. So what are fossil fuels? So fossil fuels are the remains of animals and plants from millions of years ago. The remains were compressed or squashed in the earth over a long period of time. producing fossil fuels. So if we think about, let's say, 300 to 400 million years ago, you had all different types of creatures that were roaming around, for example, in the sea and roaming around on land. And what happens is that, and you have all these microorganisms as well. And then what happens is they naturally die, and then they fall down to the ground, and then you have sediment that over millions of years, so hundreds of millions of years ago, they get like compressed, so they do. And what happens is the pressure of the water, it compresses this. And basically what will happen is these will not completely break down properly or decompose, but they'll be changed from like dead matter or material into fossil fuels. So over millions of years, what happens is these remains, they actually start to they're turned into natural oil and natural gases. And then what happens is they're stuck, if you like, underneath the ground in some form. And then what we do is we come along and we mine it. Okay, so we can take this material out of the ground and then we can burn it like coal and oil and gases and things like that. So that's essentially like the process of how fossil fuels are made. Now the problem is that it takes 300 to 400 or even up to 500 million years to make fossil fuels, so to make things like coal and oil. So there's no way for us to be able to regenerate that. Okay, once we use it up, it's gone. And the problem is that that process of burning coal is a key process that we use in order to make electricity. And electricity, as you know, if electricity runs out, if it's out for even a week or a couple of days, it's a massive inconvenience for us. So these are fossil fuels. So this is like roughly the process of how fossil fuels are made. So some of the really common fossil fuels, the main fossil fuels are, so we have coal, so you can see here that coal is being burned. And when you look at this energy that's been released, this is energy that was trapped in the plants that took the energy from the sun. So essentially that heat that's coming back when you burn coal is trapped heat energy from the sun from over 300 to 400 million years ago. That's being released when you burn the coal. Also then you have natural gases as well. So again, you have this energy that's stored in the gas, in the chemical bonds, and when you burn it, you release the heat. You release the energy in the form of heat and light. You have oil then as well. So again, we use oil, and we like have oil tanks, and we fill up our oil, and most of our central heating is run off oil. And again, oil is a main fossil fuel. And then another one is peat, and we can use peat to make turf and briquettes. So they're the main fossil fuels that we can use. Fossil fuels have held energy in Earth for millions of years. So coal can be mined and broken into nuggets of a suitable size for our fires, and we are using fossil fuels at a much greater rate than can actually be produced. So more than 3/4 of Earth's energy needs are met by burning of fossil fuels, and it's through this process that we talked about. And that's a big problem because it's going to run out. The fossil fuels will eventually run out, and we don't have 300 and 400 million years to wait for those to be replenished. So instead of using fossil fuels, what society is trying to do is they're trying to transition into using what are known as renewable sources of energy. So again, these renewable sources of energy, they ultimately will be doing exactly the same thing, turning this turbine to generate electricity, but instead of using burning of fossil fuel to do that, they want to use energy from a renewable source. So this using energy from coal and fossil fuels is a non-renewable source because once you burn it up, that's it, it's gone. But we want to try and generate this turning of the turbine to make electricity through a process of through a way that's more sustainable, that's natural. So we can use what are known as renewable sources of energy. So renewable resources can be replaced and will not run out in the short term. So some examples of renewable sources and their uses are, so for example, energy from the sun. So we can make solar panels to take energy from the sun. We have biomass energy. So instead of burning coal, we can burn some other type of material that can burn, that we can grow and replace easily. You have like energy from water. So for example, if we dam up water and get that water to run through a dam and put it under pressure, or get it to fall from a height and get it to turn a turbine. We have geothermal energy, so that's energy that's trapped down in the core of the earth, and we can tap into that and use that to heat water to turn a turbine. And we can also use wind energy as well. So these are some of the renewable sources. So let's look at some of these individual renewable sources that can be used. So one renewable source, as we mentioned, is wind. And if you if you travel around Ireland today, you'll see windmills all over the place. So wind power, turbines or windmills have blades that turn and rotate in the wind, converting the kinetic energy of the blades to electrical energy. So it's the same thing inside here. You have a turbine, and basically wind hits these propellers or hits the blades on the windmill. They make them turn around, and what happens is they turn a generator, and that generator generates electricity, and then that can be supplied into the grid. So many countries have vast areas of land and or sea containing wind turbines. So again, wind is a renewable source that can be used to turn these turbines and generate loads of electricity. Another way to turn a turbine is to dam up water like this, and then basically that water will have a lot of what's called potential energy, and then once you release it, what will happen is it'll force out at high speeds, and that forcing out at high speeds of water can then be directed towards a turbine. It can turn a turbine, and then it can generate electricity as well. So renewable, so water, this is using the energy within moving or falling water and changing it to electrical energy, for example, in hydroelectric stations like this one here. You also have biomass. So this is the burning of fuel that comes from living things, such as wood from trees. It is renewable only if the trees that are cut down are then replaced. So instead of burning like material that takes like 300 to 400 million years to be formed, you can use some kind of plant or tree that can grow very quickly, and that can be harvested and then turned into some kind of fuel that can be then burnt. But you need to be replanting and replacing these as well. So this is what's known as biomass. So you can do that with like all different types of material as long as they burn. And that again is another alternative way that you can produce that heat source that can be used to heat steam that can then be used to turn a turbine. So geothermal, so this requires us to use the heat that is beneath the ground. So water is pumped underground and warmed from the heat in the rocks. This heat energy is generated and stored in the earth. So if you go down underneath, deep into the earth, you have molten magma that is generating an awful lot of heat. So the more you go down into the ground, the more of this heat that you're going to be able to get in touch with. So if you pump water down in there, you can get that natural heat that's in the earth to heat up the water and turn it into steam, and then that steam can be used to turn a turbine as well. So again, that's what's known as geothermal. We have solar panels. So solar panels, you can see they're quite common. You see them, they're commonplace now as well. You see them all over the country. So solar panels, they basically take heat. Solar panels, they heat water that runs through them, and the energy source that supplies the heat is the light from the sun. So these panels can be used to, they can be used to directly heat water that can be used in a house, for example, if you want to have a shower. But then also as well, these panels can take the energy from the sun and turn it into electrical energy as well. And again, the sun is there. We're getting a huge amount of energy being blasted onto the surface of the earth every single day from the sun. And this enables us to be able to use some of that energy to do some useful work, for example, in the home. So solar cells, these cells are found in devices that transform light energy to electrical energy, and an example is a solar powered calculator. So if you take your calculator, for example, some of them are solar powered. They take the energy from the sun and they turn it into electrical energy, and you can use it then in a calculator. And they're what are known as solar cells. Okay, so there are some of the non-renewable sources. So what are the current and future energy requirements? So the population is constantly evolving. we are very dependent on electricity. So we have to have this constant supply of electricity in order for us to be able to progress or to live comfortably in society. So this here is an actual satellite image, and it shows, like, for example, how electrified the whole of the continent is. We can see that there's light sources here. So a satellite image of Europe shows up electrical lights from cities and towns all over the world. So all of that energy is being produced by a lot of it is being produced using fossil fuels. So we have become an energy hungry society. This means per individual on Earth, we have a very high demand and requirement for energy. So we need electricity. Most of our current energy needs are met by burning fossil fuels and also met by nuclear energy. So these two energy sources supply 93% of the world's energy requirements, and the remaining 7% comes from renewable energy sources. So this is something that they want to reduce this percentage and increase this percentage. So what are our current and future energy requirements? So the table below shows how much fossil fuels is used just to supply the world's electrical demands. So combustible fossil fuels, percentage of world electrical supply, 58.7%. That's of the world's electrical supply. Nuclear energy, it's 17.6. Hydro energy is 13.9. And geothermal, wind and solar and other is 9.8. So data on the percentage of types of fuel used to supply the world's electrical demands. So we can see here that there's a massive reliance on, like, these two here, which are non-renewable sources. So changing energy demands. So as economies and countries become more developed, the demand for energy increases dramatically. A simple example of how this is the number of cars that are currently on the world's roads. From a study done in 2014, there are now over 1 billion cars on the road, with the United States having the highest number of cars and China having the second highest. So every one of those cars are using renewable or non-renewable fuel like diesel or petrol. In addition, the world's population is also expecting and is expected to reach about 10 billion people in the next 50 years. And so our energy demands will also increase. So the more people we have, the more demand there is for energy. Energy experts predict that by the time we reach 2030, the world's energy demand will have increased by 55% compared to today. So not only will we have to use renewable energy in greater and greater amounts, we will also need to be more efficient about how we use our energy. So energy efficiency is essential, as scientists believe that within the next 50 to 100 years, our fossil fuels will run out. So the European Union has set targets for all member states to help the environment. So the European Union's goal is to reduce greenhouse gas emission by 80 to 95% by 2050, and Ireland must try to reach these target percentages. So what we're trying to do is be efficient with the fossil fuels that we have, and also as well to try and reduce the amount of, like, CO2 and greenhouse gases that are being produced. So we can no longer continue with our current dependency on fossil fuels, nor can we continue to ignore how important it is for us to begin to use renewable energy in greater amounts. So it's very important that we start to make this switch over to renewable energy. Our future in terms of energy depends on what we do now and how we begin to plan for our future energy needs. So many governments, along with trying to target using renewable energy resources, are also looking to other forms of energy. One of those energy sources is the use of nuclear power. And why has nuclear power become one of the go-to fuels for many countries? So nuclear power, even though it is a non-renewable source of energy, it's a more reliable source of energy. So nuclear power has many advantages. So high energy output, very little greenhouse gas emissions, reduces our dependency on fossil fuels, and it's very efficient in the production of energy as well. So again, as it's a relatively new technology, being able to use radioactive material to heat water to turn a turbine, and it's something that, could be used down the line to supply our energy demands. These advantages are significant and important when countries are looking to produce vast quantities of energy from lower quantities of fuel. So, however, many people have serious concerns about the use of nuclear power. The word nuclear causes worry in many people's minds, mainly due to the disadvantages of using this form of power. So there's safety issues. So if you take Chernobyl, for example, in the Ukraine, there was a massive meltdown there when the Russians were learning how to use nuclear power, and that created a whole region in the Ukraine that is uninhabitable now. Problems in storing used fuel and its disposal. So once you use up the uranium, the radioactive material, you have the waste from it, and that waste is radioactive as well, and it stays radioactive for thousands of years, so it's hard to kind of store that and dispose of it. Mining and refining of uranium, the fuel used in nuclear power stations, which can cause vast environmental and health issues. So just getting uranium out of the ground causes massive environmental and health issues. And the limited lifespan of a nuclear reactor, which is approximately 60 years. So every 60 years, the nuclear reactor has to be replaced. So again, they're not as efficient as some of the other systems that we're using today. What countries do in terms of energy use, and especially in the area of selecting and utilizing certain forms of energy, may determine the survival of our planet. Okay, so it's a massive concern in relation to future energy needs. Okay, so let's just go back and look at what we looked at. So students should be able to research different energy sources. So I've went through the different sources of energy, and you'll be able to do some research on that. Formulate and communicate an informed view of ways that current and future energy needs on Earth can be met. So looking at talking about how our current energy needs are met and how in the future we could go about meeting our energy needs. And we've discussed a few of those, and it'll enable you to be able to do some further research in this area. Okay, so thank you for listening.